So linear functions and slope. This concept is important. The cool thing is, whether it was back in high school or let's say, for example, a Math 100, you would have seen this idea of straight lines. We want to talk about how to write the equation of a line. If they give you, say for example, a point and a slope, what do we do? And then after that, we want to talk about how to write the equation of a line if they give you 2 points. But all of this centers on the concept of the slope. The slope is so important that when you get to calculus, you keep on talking about it because the idea of the derivative is no more than the so-called limit of this slope for the secant line. And we'll talk about that in these sections today. So the slope is important. The slope basically gives us an average, and that quantifier is important in all scopes of mathematics. And then also we'll talk about how to graph a straight line as well. Several ways you can graph. We'll talk about some of those today. So the slope of the line, we talk about the slope if I'm given 2 points. So if we are given 2 points, this first point that's noted with the ordered pair x of 1 and y sub 1, and then the second point x sub 2 and y sub 2. If I can find those 2 points, then is it possible from there to draw a straight line? We talk about, based on these 2 points, the slope is the ratio, that is the average, just the fraction of what's here noted as the rise, its difference with respect or divided by the run. So the rise is with respect to the change in the y values. It's the y sub 2 minus y sub 1. Now it may rise or it could fall. If it falls, it simply means that this difference, y sub 2 minus y sub 1, is negative. And so we have a slope that goes downward. And then we talk about the run, the difference of the x coordinates, x sub 2 minus x sub 1. And so this change, or this delta, this change in the y values with respect, that means divided by the change in the x values, the so-called run. Have you seen that before? Okay, so good. So in terms of the slope, there are 4 possibilities. We can have a negative slope, we can have a positive slope, we can have a 0 slope, or we can have no slope at all. So positive slope means that the graph is going upward. And we always count from left to right. So as we go from left to right, the graph goes up, positive slope. If you go from left to right, if the graph goes downward, we talk about a negative slope. If the line is a horizontal line, then we say that we have a 0 slope. And if the line is this vertical line up and down, then we say that we have no slope at all. Because remember, the slope is defined on the y values divided by the x values. But if the x values are the same, that is, if x sub 2 is equal to x sub 1, I'm dividing by 0. That means that that's not defined. So that means that for these vertical lines, it says here technically there is no slope. Now the point slope form of the equation of a line. Now the real cool thing about these equations is that what they're called is exactly what they are. So, it's almost like my uncle had he was at the hospital with my cousin's kids, and the daddy wasn't there, and so they needed somebody to name the twins. My uncle was there, and he's old drunk, and so we were worried because the doctor asked my uncle to name the two kids. So you know, we asked, we were kind of nervous. What did he name the girl? He said Nisi. We said, that's pretty cool. And then we said, what did he name the boy? He said nephew. Anyway, anyway, the point is this. And this point in some form is when you look at it, you see the point and you see the slope. So M is said to be the slope, and then the point x of 1 and y sub 1. So when you see this equation, there's no magical math. We just say point, slope, form. Okay? Or Nisi and nephew. Anyway. Okay. All right. Is it almost like a Monday? So steps to writing the equation of a line given a point on the line in the slope. So what do we need to do? So if they give us two things, the slope, and if they give us the point, then that's cool. Then all I'm doing is just inserting or plugging into this equation the value that I'm given, M, slope, and then they give me a point, x of 1 and y sub 1. After that, just simplify. And then when you simplify, that y didn't drop down. Simplify, and you want to write the equation in terms of what's called the slope-intercept form. Now, again, the nomenclature is in the equation. Slope, M, and then B is said to be the y-intercept. So here we call this the y-intercept form. Okay. It's a little bit better. I'll fix it up later. So once we finish, we want to try to write it in this form. Basically, just get y by itself. Isolate y. That's all we're saying. Once you do that, we're talking about a straight line equation. Then the number that's multiplied to x, the number that's multiplied to x is the slope, and then this free floating term over here would be the so-called y-intercept. Now later on we talk about graphing. If I have 2 points given, I just plot those 2 points, draw a straight line, go home. Right? Or if I'm given the equation in the, watch this, this is the slope-intercept form, then what I'm going to do, this is the y-intercept, that b value, I'm going to find that value on the y-axis. Find that, that's a point. Find that, put a dot there. And then the second point I'm going to find based on the concept of the slope. And I'll show you that. The slope means rise over run. So if I have a point, a fixed point, this y-intercept, I can get the next point by taking the slope. If the slope is 1 over 2, 1/2, that means that I'm going to, from this y-intercept, I'm going to go up 1, and then I'm going to go over 2. That's the second point. Connect those two, draw the straight line, go home. So, let's see. here the slope intercept form. Again, the name of the equation, it bears it out. This slope intercept. So here, that m is the slope, and then b is said to be the y-intercept. And then how to graph exactly those 3 points, what we just got through saying. Find the y-intercept on the y-axis, and then use the concept of the slope to find the second point. Again, we're talking, but let's do something, right? So here, it says write the slope, and I just copied this right out of my math lab. Couldn't get that font to increase here, unfortunately, but you can follow along with me if you do have that, on your computer or your phone, so you can see it. So it says write the point slope form of the line's equation satisfying the given conditions. Here's what they're saying. They give us a slope and they give us a point, and then so obviously I'm going to use the point slope form. So it just kind of begs it, right, in terms of what I'm going to do. So it says then use the point slope form of the equation of the line to write the slope intercept form of the equation. So once we do the first part, see in my math lab, what it's going to do, it's not going to show you this part here, this bottom piece. It's only going to show you this. It wants you to get this right first. And once you get this right, then voila, this last part pops up. So, let's see. So I'm using the equation y is equal to, y minus y sub 1 is equal to m times the expression x minus x sub 1. Now I'm following the steps. What steps? Go back. So step number 1, it says, and that is here, steps to write the equation of a line given a point on the line and the slope, given those two things. So I'm going to insert the slope and the point into the point slope form, and then simplify it, and then finish it off. That is, just write it like this. In other words, just get y by itself. Oh yeah, here's a word on the naming. We call this point here x sub 1, y sub 1. Whenever you see the subscripts, it means that they represent, x sub 1 represents a number and y sub 1 represents a number. So we say that this point is going to be a fixed point. And when you see y in x or x comma y written like that, they stay as variables. Okay. So we come back here. So here this becomes y minus the y sub 1 would be the 3 is equal to m, that's the 2, times x minus 5. Is that all right? Is everybody good there? We just plugged in. And then we're going to simplify. So here, this is y minus 3 is equal to 2x minus 10. Now, for this part in my math lab, all it wants you to do is to just write this. Y minus 3 is equal to 2 times parentheses x minus 5. You can leave it just like that. Okay? That's for that piece there. And then once you have that, we simplify, and then it says, what is the slope-intercept form? Now that slope-intercept form looks like this: y equal to mx plus b. So m is the slope and b is the y-intercept, slope-intercept form. So basically, if I come back here, this is where I left off, I'm just going to add 3 on both sides, and then I get what I want, right? So I get y minus 3 plus 3 is equal to 2x minus 10 plus 3. Then I can write the answer. This is y is equal to 2x minus 7. That's all. All right. All right, we'll do the same thing. So here, that's the m equal to 8. X sub 1 is equal to negative 3. And y sub 1 is equal to 6. So we have y minus 6 is equal to 8 times x minus a negative 3. And you can clean that up, i.e., that is to say, this is y minus 6. This is what you're going to put in my math lab, 8 times the expression x. That becomes plus 3, right? Okay. So you put that in my math lab. And then we simplify that. So this is y minus 6. To write this in that next part, because the problem is 2 parts. So this is y minus 6 is equal to 8x plus 24. And then we're going to add 6 on both sides. So we get y is equal to 8x plus 30. And that's what you want here for the second part. Okay. Is everybody happy with that? Is that all right? Okay. All right. Well, this slope has a fraction, no problem. We still maintain the same steps, right? And so this is y minus here, a negative 3. That's equal to m, which is negative 7 over 8 times the expression x minus 4. We're going to simplify that for the computer. So this is y minus a minus is plus. So this is y plus 3. I think it was one cool teacher that said, just draw a line there and you get the plus sign. I thought that was pretty neat. So this is equal to negative 7/8 times x minus 4. That's all you need there for this part. Then we simplify this. So this is y plus 3 is equal to, I'm just going to run this fraction through the parentheses, negative 7 over 8 times x. This becomes plus because negative times negative is positive. And so here that's this, you can think about it as 28 over 8, or you can simplify it. I'm going to go ahead and simplify it. Well, I better write it as it is. And then we'll simplify it next. So let's simplify that. Here, notice that in 28 and 8, what's common in those two numbers?
2.
So 2, so you would say that this is what divided by what? was that 14?
4.
Now, can't you simplify that?
Yes, by 2.
So really, 4 was the common, right?
I just did that.
No, that's fine. That's fine. No, that's good. That's good. That's good. So let's say this implies that y plus 3 is equal to 7 over 8 times x. Here, this is what, plus 7 over 2? All right. And then we're going to add 3 to both sides. So we have y is equal to negative 7 over 8 times x, plus that 7 over 2, and then this is minus 3. So this implies that y is equal to negative 7 over 8 times x. So this is 7 over 2 minus 6 over 2. So that's 7 minus the 6 is plus 1 over 2. And that's the answer. So we'll just say y is equal to negative 7 over 8 times x plus 1/2. And then you'll plug that into my math lab. Okay? Is everybody fine? Okay. Good. All right. Steps to writing the equation of a line given 2 points. So the previous examples, we were looking for the equation of a line, but they gave us 2 things. They gave us the slope and they gave us 1 point. But now, what if they give us 2 points and they don't give us the slope? Right? Can we still find the equation of a line if they give us 2 points? Well, yes. Because the cool thing about the 2 points that are given is that I can use the slope formula to find the slope. And once I've found the slope, then I can take the slope at just one of those 2 points. It doesn't matter. You choose. You choose which point you want to use. So all I need is, going back to the previous set of examples, all I need to find the equation of a line is 1 point in the slope. If I'm given 2 points, from the 2 points, find the slope. And then after that, take the slope and one of those points you choose. And you can plug those 2 things into the point slope form, and you can find the equation of a line. All right? So use the 2 points there to find the slope, and then after you found the slope, then steps 2 and 3 are actually the previous steps from the previous set of examples. Just go back and just redo the same thing you did over there. Let's see. So here we're given 2 points. So we're given this x sub 1, just 3, and y sub 1 is 6. Okay? And then x sub 2 is 7, and y sub 2 is 14. So I'm going to use that to find the slope. So the slope is said to be y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So that becomes just the difference of the y values, 14 minus 6, all over the difference of the x values, 7 minus 3. Okay. So this up top, I have 8 over 4, I get 2. So it says, type the point slope form of the equation of a line. Well, what is that? You remember that guy is y minus y sub 1 is equal to m times x minus x sub 1. I want to put our answer in that form. No problem. I have m. M is 2, right? This is m, and then just take one of the points. You can choose 3, 6, or you can choose 7, 14. The answers come out the same, so it doesn't matter which point you use. You choose. All right, so I'm going to choose. Now, personally, for me, class, I always choose the point that has the smaller numbers. right? So when I'm simplifying, I don't have to use, back when I was a kid, man, we had like these humongous calculators, right? Those calculators, man, they couldn't do that much. But we thought it was pretty cool back then. But anyway, so this is y minus y sub 1. I'm going to take 6. That's equal to 2 times parentheses x minus the 3. So that's what they want you to put here. And then they want you to, I call this guy over here, just get y by itself. That's just old, just country talk, right? Just take this equation, get y by itself, and that becomes the slope-intercept form. So this is, yes, y minus 6 is equal to 2x minus 6. So now here we're going to add 6 on both sides, so we get y minus 6 plus 6 is equal to 2x minus 6 plus 6. We get y is equal to 2x. For this problem, here's my question to you, class. What is, the y-intercept?
0.
0. Do you see that? Y is equal to 2x plus 0. So m, the slope, is 2, and the y-intercept is 0. Okay? Can we be like the Jeffersons and move on up? Can I go to the next? Okay. Use the given conditions. Again, they give us 2 points. Basically, find the equation of a line. Just repeat, do the same thing we just got through doing. I want to find the slope. This is x sub 1, y sub 1, x sub 2, y sub 2. So m is equal to the difference of the y values. That's 5 minus, that's negative 10. All over 1 minus, that's a negative 4. So this becomes 5 plus 10, that's 15, all over 1 plus 4, that's 5, that equals to 3. So I take the slope and just one of the points. I'm going to take the one that has the 1 comma 5, 1 minus 5. Because all those negatives that'll just throw you off, right? It throws me off too. So again, I always choose the easy numbers. And here's the cool thing. For all my classes, Calculus 1 and on up and above, most of the problems that I have, I would say out of 100, maybe 99 of the problems that I have for all of my homework and quizzes and exams for calculus and above, I pick even there the easy numbers. I don't want people to be racking their brains on a calculator. I want you to be able to kind of see it, in your mind. If you need to kind of, do a visual, to graph, maybe some simple graph, but then you want to be able to work it by hand, and that's what I want you to be able to see. Because I think it's something when you see it, some kind of picture, but you can write it out, and that process, I believe, helps in what's called critical thinking. You can kind of write it out yourself, and you're not relying on all the time, a calculator or a computer. Now, there are situations, mathematical phenomena, where you have to use a computer, as granted. But I think in what I call the elementary steps and trying to get there, you want to be able to somewhat have a visual where you can kind of work something by hand. And then you get to a point where you say, hey, we need to rely on maybe some kind of program to be able to find certain solutions. And that's fine. So anyway, so I have y minus 5 is equal to 3 times x minus 1. That goes here. And then simplify. So that's there. So we have y minus 5 is equal to 3x minus 3. We're going to add 5 on both sides because basically to get this slope-intercept form just simply means just to get y by itself. So I'm going to add 5 on both sides. I get y is equal to 3x. This is minus 3 plus 5. That's just plus 2. Okay. Is that all right? We have two equations or two lines that kind of throw off all of those equations. Where you get to vertical lines and horizontal lines, all that talk about the equations of the lines and this and that, you just almost throw out the window, right? And so we have two rare cases. Here, the equation of a horizontal line is just simply y equal to where that horizontal line crosses on the y-axis, whatever that point is, that becomes the line itself. So if this is the point, let's say for example, if this point is 5, that is ideally 0, 5. So then this equation becomes y equal to 5, and that's it. Okay. Now, if it's a horizontal line, what's the slope? What's the slope? So you can't see this. So if it's a horizontal line, what's the slope? Okay, so 0 and under 5 is not the same thing, right? It's 0 under 5, it's all. If it's, look, if it's a horizontal line, the slope is 0. If it's a vertical line, the slope is undefined. Right? That's fixed. Karate punch. We had our, is it ramen? Yeah. Have you had the ramen place there in Huntsville? They have one in Mid-City, and they have one, I think it's Stone something Bridge on Governors. I forget the name of it. Really cool. But, I mean, it's set up, it's probably more oriental than like the so-called Chinese restaurants that we go to. So that was really good, really good. We had it yesterday. You get through eating, it makes you want to do a karate punch. Right. Anyway. So we got horizontal and vertical lines. The next thing is there's something called the general form. I know when I was in school, they called it the standard form. Anytime I have something on my nose, these masks just makes my nose run. Yeah. This general form of the equation of a line. And back, when I was coming up, they always had the C on the other side. It was always AX plus BY is equal to C. So now I guess somebody has gotten smarter and they put the C on the same side of X and Y. Personally, I think the C ought to go on the other side. But who really cares, right? Because lunch is coming up and we'll get some anyway, so this is the standard or the general form of the equation of a line. The cool thing about this that if x and y is what this is saying, x and y are on the same side. If that's the case, then can you extract the slope immediately? Yes, you can. If x and y are on the same side, like they are here, the slope is equal to negative a over b. Okay. So here this implies that the slope is equal to negative a over b. It has to be written in this form. That is that x and y have to be on the same side. And you can quickly extract what you want. Now what they're going to do here is they're going to say if they give you an equation in the general form, one, they want you to graph, and then number two, they want you to write the equation in the slope intercept form. That is, get y by itself. And when you do that, you're going to easily see where the slope is this negative a over b. Well, let's see what they say. So using intercepts to graph this ax plus by plus c is equal to 0. How to find the x-intercept? Just let y equal 0, solve for x. Okay. How to find the y-intercept? Let x equal 0, solve for y. Once you find those 2 points, the x-intercept, that's where the graph crosses the x-axis, and then the y-intercept, that's where the graph crosses the y-axis. Just connect those 2 points with a straight line, and you have the graph of that particular line. Just in review, the equations that we've talked about so far. Well, let's look at a problem. So here it says, give the slope and the y-intercept of the line whose equation is given. Then graph the linear function. What is the slope? What is the slope? Very good. So the slope is -2. You got it. And what's the y-intercept?
Positive 5.
+5. Here it says, right, what is the equation of the line in slope-intercept form? But isn't that it? Yeah. Like, really? You give me that, and then you ask me that? So select the correct choice below. The y-intercept here is, you said 5. Good. And then the graph. So to graph, we need 2 things. There's several ways you can graph. Give me 2 points, connect them, draw a straight line, you're done. Right? The next thing is I can graph based on find the x-intercept, find the y-intercept. If the equation is written in that general form, that standard form. But if the equation is given to us it's already in slope-intercept form, use that. So the slope is -2, and then the y-intercept is 5. We got that? The y-intercept is 5, the slope is -2. Let's see. Slope -2 means that the graph is rising or it's falling? Falling, because the slope is negative, right? So let's see what that means. So here, I want you to understand the slope as being -2 all over 1. Do you see that? Okay? The -2 means I'm going down 2. The 1 for x means I'm going to the right 1. All right, so I'm going to write this out. Say this is equal I'm going down 2 here. I'm going to the right 1. But I'm doing that from the y-intercept. So I found the y-intercept is 5. So that's the y-intercept is here, 5. Then the next point, I'm going to go down 2, 1, 2, and over to the right 1. And then draw a straight line. So this idea of the slope, again, see, I went down to, went over 1. All right. That's it. So cut another. Again, I mean, it's already given, but we're going to just write it as y equal to negative 4 over 5x plus 1. They already give us the equation in slope-intercept form. So the y-intercept is 4, the y-intercept is 5, the y-intercept is negative 4 over 5, or the y-intercept is 1. What is it? The y-intercept? Okay, very good. So we're going to graph this one. I'm going to find the y-intercept, which is 1, on the y-axis. And then the slope, that's negative 4 over 5. That means to go down 4. And then I'm going to go to the right 5. From this point, so from this point here, I'm going to go down 4. 1, 2, 3, 4. Then I'm going to go over to the right 5. 1, 2, 3, 4, 5. Now these other points to get me there, those are not points on the graph. They're just helping dots so I could count it out, right? Now that makes sense because the slope is negative, this graph is falling. All right. What about this guy? It says graph this guy. What kind of line is that? If it's y, horizontal. If it's y by itself, horizontal. If it's x by itself, it's vertical. What was that again? 0. It's a horizontal line. And the question is, what kind of line is this? It's horizontal, right? So I find y equal to 6 on the y-axis, and then just draw a line that goes right through it horizontally, and you're done. Okay. It's a horizontal line. And then x equal negative 6, that's a vertical line. Right? So I'm going to find on the x-axis negative 6 and just draw a vertical line through it. That's it. Okay. Now here, they give us an equation in that general form. So what they want us to do is to find the, it says rewrite the equation to put that into the slope-intercept form. Why? It's because I want to graph it. And I didn't mean to have the answers there. I worked it out and put it there already, but it's fine. We'll walk through it. So what we want to do is to take that equation, 5x plus 7y minus 35 equals 0, and basically we're going to write this in the slope-intercept form. Just means to get y by itself. So to do that, the process is I'm going to subtract 5x on both sides, and then we're going to add 35 on both sides. So I have 7y is equal to negative 5x plus 35. You remember I told you that if the equation is given as ax plus by plus c is equal to 0, this implies that the slope will be negative a over b. So the slope would be negative 5 over 7. Let's see how that works out. So now I'm going to divide everything by that 7. So this is y is equal to negative 5 over 7 times x plus 35 divided by 7, that's 5. So that becomes the slope-intercept form, right? We got it there. And then from that, the number that's multiplied to x, if it's in the slope-intercept form, slope-intercept form, if it's in that form, then the number multiplied to x is the slope, and the number out here by itself is the y-intercept. Again, take those two numbers, and I can plot and graph the straight line. So use the slope and y-intercept to graph. So here the y-intercept is 5. I'm going to go on the y-axis and find 5. And then the slope says to go down 5 and go over to the right 7, right? So I'm going to go down 5. And then I'm going to go over to the right 7. Oh, there's the ruler there. Can draw straight lines. All right? Does that make sense? Is that good? Okay. All right. That's the same idea here. So we're going to isolate the y, but let's get just minus 4y by itself. Subtract the 7x on both sides. Subtract the 28 on both sides. So I have negative 4y is equal to negative 7x minus 28. Now divide everything by that negative 4. So I get y is equal to 7 over 4 times x plus 7. So 7 is the y-intercept. And then I'm going to go here. This guy is positive. So I'm going up 7. That's off the grid. But let's see if we can count it out anyway. 1, 2, 3, 4, 5, 6, up there. And then to the right 4. So we got something that's doing that. On your graph grid in my math lab, you'll be able to have all of those point values on the x and the y axis. So you'll see all of that. Okay, why don't you do this one? Work that one. Let's see what you get. Can you see that? It's 3x plus 3y plus 9 is equal to 0. So what'd you get the slope to be? What's the slope? Negative 1. The slope is negative 1. It's a big difference between negative 1 and positive 1. What's the y-intercept? Negative 3. Yes. So the slope is -1. So from -3 on the y-axis, I'm going to go down 1 and over to the right. Okay, very good. Any questions? All right. Here's something that's been in the news the last few years, and that's this idea of global warming. And the scientists are telling us that the Earth and its atmosphere is getting warmer. From the data, are we able to determine the cause of global warming? From the data, are we able to determine the cause of global warming? Or maybe let me ask you this in this way. The way the data is presented, what is the data suggesting the cause of global warming?
Carbon dioxide.
Carbon dioxide, which comes from, okay, so just the pollutants from cars and factories, and all right. Which you kind of think, well, obviously 200, 300, 400 years ago they didn't have automobiles and all of that. Also, I think the other issue is in terms of pollutants when it comes to plastic that's being thrown away, and how that's also affecting the so-called ozone level. What can society, that is individuals, companies, institutions, do to help mitigate global warming? Anyone? I think we've been hearing these lawsuits in the news of like 3M and these big corporations in terms of what's being put into the water and into the ground and that kind of thing. But what can individuals like you and me, what can we do? Hmm? A friend of mine just bought an electric car. He went up to Chicago and bought it as a Tesla, and he drove it from Chicago here, and he said that his cost in terms of recharging, I think he stopped like maybe 2 or 3 times from Chicago back to Alabama. I think he said he paid no more than about $12 in terms of doing that. And in my head, I'm simple. I'm thinking, well, that may be cheap now, but I'm sure when they do make this conversion to everybody go electric, they're going to raise those prices too. And it's going to be almost like getting gas again. Look, it's going to always be those big companies, they're going to win, and then the individual consumer, we're going to always pay, period. So I know years ago, I've been here 22 years, and I was here before we started online classes. And when we first started doing the online classes, our calculus course, the book reps came to us, and they were given the codes, the access codes to our online classes for the homework and that kind of thing. They were giving those codes away. I think the cost to students back then, this was, I don't know, maybe 2008, 2009. I think students were paying no more than about $12, $15 for the access. How much do you all pay now? How much?
You said the access code?
Yes, ma'am. Is how much? $100. Yeah, you're exactly right. Over $100, and it gets like that. It's for all these classes, and it's almost where it's getting where the book publishers are realizing that they're not selling the books anymore like they used to, because everybody's going to like an online base. So the cost of the books are now kind of going down, but the cost of the access for the online platform is going up. So you're gonna always have that supply demand. Yes, ma'am.
When you originally asked that question, my
Mhm.
first thought was make Teslas cheaper. More people would buy them. Less environment, like less carbon dioxide in the air. And
Yeah.
then he was like, use Teslas, and I was just, I mean, yeah, it's cheap to charge them right now, but if they do make them cheaper, everybody would buy them, and then that's when it would go up.
Yeah, and here's the thing, and I talk about the cost. They're not concerned about the cost for us. They're just talking about in terms of this the pollutants that's in the air. Obviously, if they can stick it to us, they're going to, in terms of how much they charge the consumer, because the companies want to get rich, and they want all of us to pay for it. So now here's something to think about. Here's a good question. I should have put this on there. What if there were no automobiles and all these factories putting out all this pollutant in the air? Do you think that there would still be a problem with global warming? Do you think global warming would be an issue? You say yes?
Probably.
I'm thinking so, and here's the only reason why I think so. And I could be wrong, but I just believe the Bible. The Bible says everything's going to burn up one of these days, and the one who's behind that lighting the match is not us, it's God. I'm going to move on.
Revelation.
Pardon me?
The book of Revelation.
Yes, and the book of 2 Peter, the book of Jude. That's right. Paul makes reference to it, Peter. So, but anyway, I don't want to religionize. Is that a word? We don't know. This class, but I think there's something to that. So anyway, the next section